guys, this is Archana from Edureka and I welcome you all to yet another session on software testing. Today's topic of discussion is integration testing. But before we proceed any further, let's go ahead and take a look at today's agenda. So we will begin this session with a brief introduction to software testing and different levels of software testing. Then we will get started with our today's topic, which is integration testing. We will learn what integration testing is, different approaches to integration testing, how to perform integration testing. We will also learn what integration testing is with help of an example. And finally, we will conclude this session by discussing different challenges that you might come across and best practices that you should follow when performing integration testing. So I hope agenda was clear to you guys. Let's get started then. So guys, before software is released to market, it undergoes rigorous testing. And I'm pretty sure you guys already know that. Testing is an integral part of any successful software project. Software testing basically is the process of executing the software or an application to find out if there are any bugs or some sort of errors in it. So before software actually goes public, programmers spend hours trying to iron out every little bug. They check for any mistakes and problem in the design and the functionality of an application or a software. Until then, product won't be available for commercial use in the market. Well, there are mainly 4 stages of testing that need to be completed before a program or an application can be cleared for use. Namely, we have unit testing, integration testing, system testing, and acceptance testing. The first level of testing, unit testing, is the micro level of testing. It involves testing individual modules or units to make sure they're working properly. A unit here can be anything. It can be a functionality, a program, a particular procedure of a function within an application. It can be anything. Unit testing helps verify internal design, internal logic, internal parts, as well as error handling. After unit testing, we have integration testing. Integration testing is done after unit testing. This level tests how the units work together. Individual modules are combined and tested as a group. It's one thing if units work well on their own, but how do they perform together when combined? Integration testing helps you determine that and ensures your application runs efficiently. It identifies interface issues between modules. Well, there are different techniques that can be used for implementing integration testing. We will discuss more about them later since the topic of today's discussion is integration testing. The next level of testing is system testing. As the name implies, all the components of the software are tested as a whole in order to ensure that overall product meets the requirements which are specified. So basically, system testing is particularly important because it verifies the technical, functional, and business requirements of a software or an application. Well, there are dozens of types of software testing, like you have usability testing, regression testing, functional testing, and many more. If you guys want to know more about these testings, you can refer to Edureka software testing YouTube playlist. We do have videos on different type of software testing there, and do subscribe the Edureka channel if you like them. Getting on with our today's topic. The system testing is usually done by testing team, and it includes a combination of automation testing as well as manual testing techniques as well. And the final level of testing is acceptance testing, or basically we call it UAT, which is user acceptance testing. It determines whether or not the software product is ready to be released to market. Well, let's face it guys, requirements keep changing throughout the development process, right? So it's important that the tester verifies the business needs are met before the software is released into production. So are the functionality or the functional requirements met, or the performance requirements met or not? Well, these are the questions that you ask in this level of testing. So UAT is the final say as to whether the application is ready for the use in real life or not. So basically each level of testings, that is unit testing, or it could be integration testing, system testing, acceptance testing, each have their purpose and they provide value to software development lifecycle. So the most basic type of testing is unit testing or component testing. The main goal of unit testing is to segregate. It isolates the smallest piece of the testable software from the remainder of the code and determines if or not it behaves exactly as you expect. Generally, we refer to those small pieces of software as unit. But the problem is, although each software module or unit is tested, defects still exist for various reasons. Let's check few of them out. For example, a module in general is usually designed by an individual software developer whose understanding and programming logic may differ from other programmers. And sometimes programmers are highly skilled and very creative. They won't read all the design specs or approach coding features the same way like others do. Well, this can lead to disconnects and glitches when their modules must talk to each other. So there's a clash between different modules developed by different developers. Secondly, unit tests work with internal module communications using software stubs that simulate the rest of the systems. Well, these stubs are make-do workarounds, and when the system's module have to communicate, features like data formatting, error trapping, hardware interfaces, and third-party service interfaces tend to have unforeseen issues that were not observable at the unit-level testing. That's another problem. Well, at the time of module development, there are wide chances of change in requirements by clients, right? Because user requirements keep changing. These new requirements may not be unit tested, and hence we have to perform integration testing. Similarly, you might have external hardware interface issues as well. Inadequate exceptional handling could also be a problem. So even after performing unit testing, even after testing each module specifically, you do come across these problems. So as a solution to this, we perform integration testing. So keep in mind, no matter how efficient each unit is running, if these units aren't properly integrated, it will affect the functionality of the total software program. To avoid all these issues, integration testing is introduced as a level of software testing. Integration testing is done to test the modules or components when integrated to verify that they work as you expected. That is, to test the modules which are working fine individually does not have any issues when integrated. So the meaning of integration testing is quite straightforward. Integrate or combine the unit tested module one by one and then test the behavior as a combined unit. That's what integration test means. So we normally do integration testing after unit testing, as you guys already know it. Once all the individual units are created and tested, we start combining those unit tested modules and start doing the integration testing. So once again, the main function or goal of integration testing is to test the interfaces between these modules. Not the modules, but the connection or the communication or the interface between these modules. That's the aim of integration testing. Let's learn more about integration testing. Integration testing basically makes sure that integrated modules and components work properly. Integration testing can be started once the modules to be tested are ready. While it does not require the other modules to be completed for testing to be done. And how is that possible? We'll check that out later. And integration testing also helps detect the errors which are related to interface between the modules, like I said earlier. It is also helpful when there are frequent requirement changes. It's very common for a developer to deploy changes without unit testing sometimes. So integration testing can help when the modules need to interact with APIs or some sort of third-party tools. You can test the modules to find out if the third-party tool accepts the module's data or not. Integration testing typically covers large volume of your system than a single test, so it's more efficient. And lastly, writing both unit and integration test increases the test coverage at faster speed and it improves the reliability of your software. So well, these are the advantages of using integration testing. Here I have a simple diagram for you to understand what integration testing is. As you can see, I have 4 levels of testing. We begin from down, we have unit test, integration test, end-to-end is nothing but system testing, then UI test, that's nothing but acceptance testing. As you can see in the diagram, we have the red coded part, which is a small unit or a module. It's tested. Then it's combined with other unit, and these both are encoded, as you can see in the green part. So that's integration testing. You're combining 2 modules and you're checking out the interface or the communication or the interaction between these modules. That's integration testing. As next level, obviously, you have system tests that you combine multiple modules and check them as a whole. And lastly, you have acceptance test before the product or application is released to market. So it's as simple as that. So before we proceed any further, here's one more question. Who performs integration testing? Well, software engineers or developers usually perform integration testing. However, there are instances when the company employs independent testers to do it for them. So guys, there are different approaches to perform integration testing. But before that, you should note that integration testing does not happen at the end of the cycle. Rather, it's conducted simultaneously with the development. So in most of the times, all the modules are not actually available to test. So the challenging thing here is, how do you test something which does not exist? For that, we have a concept called stubs and drivers. So sometimes we might face a situation where some of the functionalities are still under development. So the functionalities which are under development will be replaced with some dummy programs. These dummy programs are named as stubs and drivers. Let's check what they are. So here I'm considering a single application, and this application has two components. Component 1, which is login page, let's say module A, and we have module B, which is admin page. As you can see, login page is dependent on admin page. Now suppose if you have to test login page, developers have developed the login page and they have sent it to the testing team to test. The problem here is that admin page is not yet developed. So what do? Instead of the actual admin page, you create a dummy admin page, which has same functionality of the original one, but not all the core functionalities. And then, since login page is dependent on dummy page, you check the functionality of the login page in linking with admin page. So without waiting for another module to be developed, you finish the testing. Here, the dummy admin page is what we call stub or a called program. Next, coming to drivers. It's just reverse of stubs. Let's say you have to test the admin page. It's ready, it's developed, it's been sent to testing team for testing. But the problem is login page is not yet developed. What you do, just like you created dummy admin page, here you create a dummy login page which is dependent on admin page. So this dummy login page is what we call a driver. It's called a calling program. So now you know the difference between stubs and drivers, right? Stubs is a call program and drivers is a calling program. So now that you're aware of these concepts, which is stubs and drivers, let's get started with different approaches to integration testing. So basically there are three types. To begin with, we have top-down approach. The top-down approach starts by testing the topmost modules and gradually moving down to the lowest set of modules one by one. And then we have bottom-up approach, which is exactly opposite of that of top-down. So in bottom-up approach starts with testing the lowest units of application and gradually moving up one by one. And then we have something called Big Bang testing. This Big Bang testing involves testing the entire set of integrated modules or components together simultaneously. Since everything is integrated together and being tested at once, this approach makes it difficult to identify the root cause of problems. We will discuss more about advantages and disadvantages later on. Let's explore each of these techniques in detail. So let's begin with top-down approach first. So like I said earlier, top-down approach testing takes place from top to down following the control flow of software system or architecture. So high-level modules are tested first and then low-level modules, and finally integrating the low-level modules to a high level to ensure the system is working as it's intended to. But it's quite possible that, like we discussed earlier, when we are testing the high-level modules, lower-level modules might have not been developed yet. So what do in such cases? You deploy stubs. Like we discussed, stubs are dummy modules that simulate the functionality of a module by accepting the parameters received by the module and giving an acceptable results. Basically, it acts as a dummy missing module. Generally, stubs have hard-coded input and output that helps in testing the other modules integrated with it. So for you guys to understand top-down approach in a better way, I have an example here. I have 7 modules. Module M1 is dependent on M2, M3, and M4. Similarly, M3 depends on M5 and M4 depends on M6 and M7. Now, while performing top-down approach, we begin with a granular module, the first one, which is module M. So you want to test module M. As you perform unit testing, it's working well and fine. Before you even start with integration testing, all these modules undergo unit testing, so they're well and fine. Now that we start integration testing, the module M1 depends on M2, M3, and M4. We want to check module M1. But M2, M3, and M4 are not yet ready. What you do? You employ or deploy stubs instead of these original modules since they're not developed yet. These stubs simulate the activity of M2, M3, and M4. Similarly, when you're testing M3, it depends on M5, and if M5 is not ready yet, you again use a stub here. Same goes for the next level of testing, which is M4, which depends on M6 and M7. Easy to understand, right, with the help of an example? So that's what stubs are. These are called programs. And one more thing, simple applications may require stubs, which would simply return the control to their superior modules or high-level modules. More complex situation demands that stubs stimulate a full range of responses like parameter passing and many other features. These stubs may be individually created by tester, or they can be provided by software testing harness, which is a sort of software specifically designed to provide a testing environment. So in top-down approach, if the dependent modules are not ready yet, we use a concept called stubs. Well, just like any approach, this approach has advantages and disadvantages as well. The tested product here is extremely consistent because integration testing is performed in an environment which is mostly similar to real world environment. Secondly, the stubs in top-down approach can be written in lesser time compared to drivers because these stubs are simpler to author. Here, fault localization is also very much easy. In top-down approach, the critical modules are tested in priority, which further helps tester in finding major design flaws early in the stage of testing. Detecting major flaws is done very early in the process. Coming to disadvantages, as you can see, if the modules are not developed or ready yet, they require several steps. Modules at lower level of software are tested inadequately when compared to other modules. And the most popular disadvantage that you have to remember is that the basic functionality of the software in top-down approach is tested at the end of the cycle. That can be a problem sometimes. That's all with top-down approach. Let's go with next approach, which is bottom-up approach. Well, it's complete opposite of top-down. Here, the bottom level units are tested first and upper level units are tested then step by step after that. So here testing takes place from the bottom of the control flow to upwards. Again, it's possible that the higher level modules might not have been developed by the time lower level modules are tested. Just like we use stubs in top-down approach, we use something called drivers here. These drivers are calling programs. They simulate the functionality of higher level modules in order to test lower level modules. Let's consider the similar example which we did earlier. As you can see, I have 7 modules: M1, M2, M3, M4, M5, and M6 and M7. M1 dependent on M2, M3, and M4, and M3 on M5, M4 on M6, and M7. Now, each of these modules are unit tested, so that's well and fine. So we begin here from the lower level. So we start with M5, M6, and M7. But as you can see, M3 and M4 are not developed yet. So what you do, you replace this M3 and M4 by drivers, and then you test M5, M6, and M7. Same goes for M3 and M4 if M1 is not ready yet. And same goes for M2 because M1 is dependent on M2. And if M1 is not ready, we create a driver which simulates the functionality of module M1. Here, just like stubs, the driver can have different functionalities. The driver would be responsible for invoking the module under test. It could be responsible for passing the test data, or it might be responsible for receiving the output data. And similarly, just like stubs, the driving function here can be provided through a testing harness or may be created by tester as a program. So that's the choice that the tester have to make here. Coming to advantages, in this approach, development and testing can be done together. So the product or the application here will be efficient and it will be according to customer specifications. The time requirement here is comparatively less and tester conditions are much easier to create here. Coming to disadvantages, just like top-down approach, the bottom-up approach also provides poor support for early release of limited functionality. And the need for drivers, because we use drivers, right, if the modules are not developed, it complicates the test management. Sometimes high-level logic and data flow are tested late during the test process. And even the key interface defects are found later on than earlier stage. So these are the disadvantages. And then after that, we have another approach called Big Bang approach. Once all the modules are ready after testing individually, this approach of integration testing combines them at once and perform testing. That's what Big Bang testing is. So instead of just starting from top or down, it just combines all the units or modules once they are ready and performs testing at once. Though Big Bang approach seems to be advantageous when we construct independent modules concurrently, this approach is quite challenging and risky because when you combine all the modules and test them at once, and if there are any errors, it's difficult to find out what is the reason for error since all the modules are combined and tested at once. I'm going to take similar example here. There's nothing to explain. It's pretty straightforward. All the modules are unit tested. Then you wait until all the modules are developed. You don't use any stubs or drivers here. Once all the modules are developed, you combine them and test them as a unit, as a combined unit as a whole. So that's what Big Bang testing is. And we have advantages and disadvantages. Talking about advantages, as you can see, all the components are tested at once. So it saves a lot of time because we don't use any stubs and drivers, and also it saves a lot of time. And this process is convenient for smaller systems because there'll be less number of modules to combine or act on. Coming to disadvantages, you'll have to wait for each of this module to be developed, right, before you start testing. So a lot of time is wasted or delay. There's a lot of delay before you actually start Big Bang approach. And since there are a lot of modules which are combined and tested at once, it's difficult to trace the cause of failures if there are any. And sometimes it's quite possible that when there are so many modules, few interface links between some modules might be missing and you will not even notice that. And as you can see, no module is prioritized, which sometimes might be problematic. Critical modules need to be prioritized sometimes. So these are the disadvantages. So to overcome the limitations and exploit the advantages of each of these top-down, bottom-up, and Big Bang approach, we have something called sandwich integration approach, or it's also known as hybrid testing approach. Well, as the name suggests, it is a mixture of two approaches like top-down approach as well as bottom-up approach. In this approach, the system is viewed as three layers consisting of the main target layer in the middle, another layer above the target layer, and the last layer below the target layer. So three layers. As you can see, M2, M3, M4 are the middle layer, the target layer. M5, M6, M7 are the layer below that, and M1 a layer above target layer. So the top-down approach is used in the topmost layer, that's layer 1, and bottom-up approach is used in the lowermost layer, which is layer 3. It might sound a little complicated, but sandwich approach is very useful for large enterprises and huge projects that further have several sub-projects. And sometimes when development teams follow a spiral model, the module itself is as large a system. Then you can use sandwich testing. The resources that are required here are immense, and big teams perform both top-down as well as bottom-up method at once or sometimes one after the other. So basically here you use the advantages of both top-down as well as bottom-up. Well, obviously this process, as it looks complicated, it has a lot of disadvantages. Since both top-down and bottom-up are executed at the same time or one after the other, the cost of testing is literally high. It cannot be used for smaller systems because the interdependency between the modules is quite complicated. It also makes sense that when individual system is as good as complicated system, then sandwich integration is best. And obviously you're using different approaches here. So the development team or the testing team should have different skills to ensure that the testing is done in a proper way. So these are the disadvantages. Moving on to next topic, let's see how you actually perform integration testing. Well, it's highly similar to any of the testing process, just like unit testing or any other testing. So the first thing you do is choose the module or the component which you have to test, and you also select the strategy that you want to employ out of the strategies which we just discussed. And before you actually proceed, you have to make sure that each of these modules which you have selected is unit tested already. Then you deploy the chosen modules or the components together, and you make the initial fixes that are required to get started with integration testing. Then you perform functional testing and test all use cases for the components chosen. Similarly, you perform structural testing and test the component chosen. After you've done all the testing, you record the results of the above testing activities. You repeat the above step until the complete system is fully tested. As in, you combine two modules, test them, and again, everything is proper, you combine with third module and do the same thing again and again. So to summarize, very simple. First, you should prepare a test plan. Then you design test cases, test scenarios, test scripts according to your plan. Execute the test cases, followed by reporting of defects. Now track and retest defects as soon as they arise. And then you follow the entire process again and again until your entire system is tested. So that's how you perform integration testing. Simple, right? Moving on to the next part of the session, I'm sure you guys have understood what integration testing is by now. But anyway, let's go ahead and try to understand it in much better way with help of an example. So as you can see, I have three modules here: a login page, a mailbox, and a delete email page. So like I said earlier, integration testing majorly focuses on interfaces and the flow of information between these software modules. So priority here is given to the integrated links instead of the unit functions that are tested in advance. So you do not have to focus on testing the login page as it's done already in the unit testing. You should focus on its interface link with the mailbox page. Similarly, check the interface link of mailbox with the deletes email module. So let's go ahead and take a look at the test cases. So the first test case objective here is to test the interface link between the login page module and the mailbox page module. So the description, you enter the login details and you click on the login button. As soon as you do that, you should be taken to the mail page. If that's happened, it means that the interface link between your login page as well as mail page is working properly. Similarly, we have second test case to check the interface link between mailbox and delete email module. So what do? You go to mailbox, check the email that you want to delete and click on delete option. As soon as you do that, it's quite straightforward that email should be deleted. That's not what we're checking. What we're checking here is that the deleted email should appear in the trash folder. So that's the interface between the mailbox and the delete interface page. So integration testing, like I said earlier, is all about the interfaces between modules, not about the functionality of individual module. So guys, like any other testing, integration testing also has challenges that you might come across. For example, integration testing means two or more systems are integrated to ensure that system is working properly. So not only the integration links are to be tested, but exhaustive testing related to environment should also be performed. It ensures that all the integrated system components are working properly. There are different paths and permutations to apply for testing the integrated systems. So basically, test data management becomes difficult because you have multiple test cases and different paths and permutations that you have to follow to perform integration testing. It's tough managing integration testing sometimes because you have various factors that you should consider like database, platforms, environments, etc. Similarly, whenever a new system is integrated with a legacy system, it needs a lot of testing efforts and changes. Same goes when you're combining one legacy system with other legacy systems. In such cases, you have to develop test cases which test the entire unit functionality or combined unit functionality. So developing test conditions and test cases also becomes quite challenging. And lastly, when you're integrating two systems developed by two different companies, it's a big challenge for programmers. No one is sure how one system will affect the working of another system. So to minimize this impact, several considerations should be kept in mind to make integration more successful. Well, we cannot avoid all this, but you can follow certain practices to at least make the effect of these challenges a little lesser on your testing. First of all, you need to check if the testing strategy that you've applied is suitable one for your requirement, that is for your application requirement or software requirement or not. And based on the test strategy that you've chosen, and if you're sure it's right, you prepare the test data and test plan accordingly. After that, you need to focus on the architecture design of an application and identify the critical modules. These critical modules should be tested on priority. And then you get the interface design for the application from the architecture team and generate test plans to verify interfaces in detail. So the main concept or goal of integration testing is to check the interface link between modules, right? So you need to have the basic understanding of the interface architecture. Each of these interfaces, like database, external hardware, or any other software application, should be tested and should be understood in detail. Test data plays a critical role in any integration testing, so you have to take into consideration that as well. So keep mock data handy before the execution of test cases. So do not decide on the test data while executing test cases itself, because as you know, the user requirements keep changing. And according to that, you might have to change the data that you want to test on. Apart from these, I have few things which I've put up on the screen. As you can see, you need to identify each module, check how data is communicated, understand the user requirements, create multiple test conditions according to those requirements, and focus on one condition at a time. So these are certain things that you can follow to make integration testing much more simpler and less complex. So guys, that's all about it. Integration testing, its types, examples, strategies, practices, challenges. We have discussed everything. I've tried to explain what integration testing is with an example for better understanding of the concept. So integration testing is an important part of testing cycle that makes it easy to find defects when two or more units are integrated. So that's all about integration testing. So guys, if you have liked the video or if you have enjoyed listening to this session, please do click on the like button. And if you have any doubts or any queries, please do post them in the comment section and we will get back to you as soon as possible. Thank you guys, and I'll meet you in next session with another interesting topic.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!